So we're going to go over the quizzes on Chapter 9. Section 1 quiz, which is quiz 14. Let's talk about these. So it says, the characteristic is by the transfer of electrons from one atom to another. If it's going from one atom to another and transferring its electron, it's always going to be ionic bonding, right? Number 2, the characteristic by sharing a whole sea of delocalized electrons just flowing through, it's going to be with the metals, right? Because they conduct electricity too, but metallic bond, number C. Number 3, produces substances that are characterized by malleable and ductile. What's malleable and ductile? Malleable is when you can hammer it into shapes and bend it up. Those are like metals, right? And the ductile means you could put it in ducts. So basically, or into wires. So basically, this is going to be metallic. So C. So on to number 4, cations. I hope this is centered right so you can see it. So cations are attracted to anions. Well, that happens in ionic bonding, right? Ions is the glue, right? So it's ionic bonding. You've got cations are positive and negative ionic bonding. So it's present in SO2. SO2 is like H2O, or kind of like present. It has a covalent bond there. It's not ionic. It's two substances that are not metals, so it's going to be covalent bond, most likely. The present of two metals, you got aluminum and nickel, and these are two metals, so it's going to be what? Metallic. You got two nickels, aluminum, nickel. You can look these up on your periodic table too. So number 7 is present in calcium and fluorine. So one is calcium is clear over on the right side, and fluorine is clear over on the left side on the periodic table. So that means that this is going to be very ionic because one is clear over on this side, and then this one is in column 2. Calcium is in column 2, and this is in column 17. So you know they're too far apart, they're going to be ionic. And those are the columns of the periodic table. According to the what rule, atoms tend to react to achieve a noble gas electron configuration. So what's a noble gas? It's going to be 8. They want to fill up their electron shell with 8. So it's called octet. Octet is 8. So it's the octet rule. So let's see if here we go. Unequal sharing of electrons produce what kind of bond? A polar bond, right? So if you have unequal sharing, you have one pole's unequal. So the unequal sharing, one pole's going to be positive and one pole's going to be negative. So an unequal sharing, it's not going to be equal, so it's not going to equal out. You're going to have a positive side and a negative side. The stronger poles I put on there is negative. A bond that involves sharing 4 electrons is what? When they share 4 electrons, they're sharing those 4 it's going to cover a double bond. If they're sharing those 2 electrons is single, but 4 electrons, so they're sharing 4 electrons is in a double bond. They end up sharing 6 electrons, it's going to be a triple bond, right? So that's your quiz for that section. So let's go on to the next quiz. Okay. Quiz 15. A bonding situation which electrons are shared by more than 2 atoms is called what? They're known as delocalization. So those delocalization means electrons are shared by more than 2 atoms, sometimes by tons of atoms. They call them free or delocalized electrons. So what did I put? True, false? That's true. Electrons that circulate freely through a molecule instead of being bound to a single atom or a pair of atoms are said to be deconvoluted. No, it's not deconvoluted. It's false. It's delocalized. We just had it up there. Delocalized. So delocalization, delocalized. So this one's false. A molecule that has a symmetrical, that means they're both equal sides, distribution of polar covalent bonds will be nonpolar. Yep, when it's symmetrical and they're equal, they don't have any poles. They're all both equal. So this is true. Number 4, a formula in which non-bonding electrons are shown as dots around the atoms and bonds as lines are shown as dots between is called the Pauling structure. No, we didn't use the Pauling structure. What structure do we always do that with dots? It's called the Lewis structure, right? That's wrong, false. So let's go on to number 8. Hopefully I'm situated here so you can see it. Predict the geometry of the following molecules. Okay, the geometry, remember we had those different types. We had the types that had two different molecules were angular and basically, what did I say? Angular and single. And then we had the trigonals, 3, and we had the trigonal, 2 different trigonals means 3, and then we have the tetrahedral. So anyway, so predict the geometry. When you look at this geometry here, what do you see? 1, 2, 3, right? And you have 2 at the top, which are going to make these 3 come down. So these 3 are going to come down. These 2 are going to come down because these are going to pull them down. So it's going to look like a pyramid. It's going to look like a tripod. So this one would be trigonal pyramidal, this one. So let's go on to the next here. And predict the geometry of this one. So what does this look like? And I would put D angular, because what will happen here is basically see these would be force them down, and so this would be an angular one. So, and it only has 2. So it could only be angular or linear. So, and it kind of looks linear too, but it's angular. You might want to look this one up even further. Predict the geometry of the following molecule here. So here we have it going up the other direction, but you also have, as it's not only just going up in the other direction, you have the carbon. The carbon is actually being used, so you don't have any non-bonding, you don't have any dots. So it's oxygen. So this is going to be 3, because you have 1, 2, 3, so a trigonal planar, because there's no, only when you have, like this one up here had the 2 dots, that makes them pull down like a tripod. There's no dots here because the dots are used up with the oxygen here. So basically, because they're used up, this is going to be all in one plane. So they call that trigonal planar, all in one plane, like just in that one, a flat plane, 2-dimensional. Predict the geometry of the following molecule. Here's another one. 1, 2, 3, 4. We have 4 of them, so it's going to be tetrahedral. Tetra meaning 4, right? A. Okay, the molecule in which 3 atoms are arranged in a straight line are said to have linear. They're in a straight line. 3 atoms in a straight line, linear. Which of the following statements best explains why ammonia, NH3, is polar, but boron, trifluoride, is not? So, and I didn't have, you can read them over, but one thing about ammonia, it has bonds that are asymmetrical, and boron has bonds that are symmetrical. So asymmetrical, and that's ammonia. It's very asymmetrical, so it's going to be more polar, and then this is symmetrical, so it's going to be less polar. Asymmetrical has a positive and negative, so you can discuss that too. So, going over some of the questions, in the midst of your test here. So, let's just kind of talk about some of these. So, what property is used to protect or predict whether a bond is primarily ionic or primarily covalent? Ionic bonds are very electronegative. they attract very, very much each other, the ions and the cations together from the left side to the right side of their periodic table. So electronegativity is one of the, with ions, very important. Which of the following is not a difference between compounds and mixtures? So you're looking through those, let's look through them all, and then you look and say compounds are always homogeneous, but mixtures are always heterogeneous. That's wrong. If you look in there, because mixtures can mix up pretty well. It looks pretty good, but then if you raise the temperature, the salt or the precipitates come out of it, so they can be homogeneous. Homogeneous. I say it means that they're all one same. They all look like a same mixture together, and then heterogeneous look like they have pieces floating in it, right? But that doesn't mean that they are compounds can be either way. So anyway, what causes the bright colored lines in the spectrum of glowing hydrogen gas? We discussed that before, huh? So what happens when the gas glows? Well, there's electrons that are dropping to the higher levels, and so when they drop to the higher levels, they're letting off these photons, and so they're letting off energy. So when electrons drop to lower levels, from higher levels to lower levels, you get these colors. They always have to go from higher levels to lower levels, and then that produces energy, or photons are emitted that give light. What does absolute zero equal? Well, 0K is absolute zero, right? We know that. But also, if you change it to centigrade, negative 273.15, that is absolute zero too. So both A and B. What is the heat required to cause a unit rise in the temperature of a unit mass? Well, that's specific heat. That means the others are heat of reaction. No, it's not the heat of reaction. Heat of formation. No. Heat of fusion has to do with melting. No. Specific heat. Number 6. Which of the following equations is the usual form of the ideal gas law? You might have to look this up, but if you look here, the ideal gas law always has PV together, because they are going to be opposite. So PV, pressure and volume, are always opposite. So when you looked in here, if you couldn't remember this, and I had a hard time remember it too, because some of these are from earlier lessons, but pressure and volume are always going to be opposite. So it'd have to be one where the PV were together. What type of bond results from the sharing of 4 electrons? So if you have 4 electrons, you're going to have you're sharing those 4 electrons, basically, like 1, 2, 3, 4. In the midst of this, they're sharing it. I guess you could go like that. They're going to share it. That's going to have a double bond. So what term refers to a very hard substances such as diamond, silicon, carbide, and quartz? What are those called? Those are called networks, right? Covalent networks. What covalent bond, that's covalent means sharing, in which the bonding electron pair is pulled closer to the more electronegative? So it's basically you have a covalent bond and you have a positive and a negative side. You would call that with polar. You have a poles. You have a positive pole and you have a negative pole. Polar bond. These are not that hard, are they? What does the uncertainty principle state about the position and momentum of small particles? Do you remember that? Basically, that momentum and position cannot be measured simultaneously, so it's very uncertain. So if you can't measure the momentum and position together and they don't work together, then it's uncertain. So B. Which of the following about gases is not true? So when the temperature of a gas decreases, think of that, the temperature decreases, its volume increases. No, when the temperature of a gas decreases, its volume increases if pressure is constant. So if the temperature goes down, the volume is going to go down, right? So here we have, in fact, you look at this here, this problem here, you have temperature over here, and as for volume here, so temperature is going to be equal volume plus, anyway, so this is going to be a false statement. So let's go on here. What determines an atom's identity as an element? So if you look on your periodic table, in the left hand, it would have its identity. What do you call that number? Atomic number. And what is that atomic number? The number of protons, right? It also can be the number of electrons, because electrons are usually equal to protons, but not always. Electrons change with ions. So the identity is going to be in the number of protons in it. Which of the following about exothermic reactions is not true? Well, exo means to exit heat, right? And number D says heat is absorbed. No, heat is going to be given off when it's exothermic, gives off heat. What principle states that elements tend to react chemical to achieve a noble gas? Noble gas means has 8. What do you call that? Octet rule, right? It wants to go to noble gas, it wants to go to 8. 8 is octet. Okay, here's 15 through 21. So let's see if you've got this all. Here we go. Characterized by the sharing of one or more electron pairs between two atoms. If they're sharing, keyword is sharing, is covalent. It's keyword, covalent, co-sharing, right? Type of chemical bond present between atoms in such substances as CaBr2 and NaCl. Oh, this is going to be easy because NiCl is a crystal. NiCl is your sodium chloride. Na is clear on one side and chloride on the other, so they have to be ionic bonds. It's an ionic bonds. One's clear over, and this is in column 1, and this is in column 17. It's got to be ionic. Characterize the sharing of valence electrons with many neighboring atoms forming a sea or cloud. Which one of those form a sea or cloud? Metal, right? Metallic bonds forms that big sea or cloud. Sea. Tends to produce solids that are malleable and ductile. Well, what are those? Metals. If you pound metals, you bend them up, right? You don't break them. And ductile, they can be put in wires. And so they will be metallic. The type of chemical bond present between atoms in such substances as nitrogen, oxygen, and CH4 anyway, my mind went blank. But anyway, these, if you have two nitrogen, you have two oxygen together and holding together, this is going to be a covalent bond. You know, because they're not ions, are they? They're not going to be ions. So, and it would have to be covalent. So characterized by the transfer of electrons from one atom to another. Whenever you find the electrons, transfer of electrons, you're going to make ions. Ionic, B. The type of chemical bond usually formed between a metal atom and a non-metal. So when you have metal and a non-metal, you're going to have ionic, just like, so you're going to have between a metal and a non-metal. Two metals are going to be metallic. A metal and non-metal is going to be ionic, predominantly ionic. And then if you have no metals, it's probably going to be covalent. True, false, number 22. The second law of thermodynamics, my favorite law, because it actually disproves evolution. The second law of thermodynamics states that the enthalpy, it's not enthalpy, right, of the universe is always increasing. No, the enthalpy has to do with heat. Enthalpy is heat. Entropy it's always going to be decreased. It's always going to go from order to disorder, right? So that's false, and you're going to have to put in entropy. Elon Musk, he said that's what he fears the most is entropy, because everything is getting more disorderly. That's what sin does, right? But anyway, number 23, a molecule of carbon dioxide in which polar bonds point symmetrically in opposite direction is polar. No, if they are symmetrical, that means they're equal. They don't have poles. They're all equaled out. It would be nonpolar. Anything that has symmetry would be nonpolar, so that would be false. The speed of light in a vacuum is approximately 3.00 times 10 to the 8 mil. Yep, that's perfect. That's what it is. Number 25. A solid whose particles are characterized by regular repeating three-dimensional patterns. What do you call when they're regular? It says it's an amorphous solid? No, it's crystal. Amorphous means basically random. Crystalline, so you have to false and it's going to be crystalline. Atoms that are of the same element but differ in a number of particles in the nucleus are isotopes. Yeah, that means isotopes means basically the protons and the neutrons, right? Neutrons. If it has more protons and neutrons, if it has more neutrons, it's going to be an isotope. Different numbers of neutrons. So that was true. The kinetic energy is associated with objects' position. No. Position, no, that's potential. Kinetic energy has to do with what? Motion. The simplest repeating unit in a crystal is a unit cell. True, we just had that. Short answer is 29. Which of the three main particles that compose the atom has a negative charge? I hope you know that electrons have a negative charge and the protons are positive. Name phosphorus what with 5 on it. So here's how I remember how you name these. This was back in the beginning here. We put down, this would be phosphorus P, and because it has 5, pentachloride. So it's penta, and then you always end with ide. So phosphorus pentachloride. What term refers to a bonding situation in which electrons are shared by more than 2 atoms? We called that delocalization, didn't we? We just had that too in the last quiz. Which type of chemical formula is the simplest ratio of atoms in a compound? The simplest ratio is always going to be the empirical formula. That will bring the simplest ratio. Write the formula for sodium sulfate. Sodium sulfate. You need basically sodium sulfate is going to have basically SO4, and you know your sodium is going to be +2, and this is going to be needing minus like that. Anyway, sodium sulfate. How long is a 2.54 centimeters? Now you want to find how much 2.54 centimeter is in millimeters, so you're going to move it over a few places, right? You're going to take this number and move it over. So if you move this one over, you're going to move it over how many places? We're actually going to move it over. So you're going to have more. When I say move it over, you're going to have to move it over to the right, because you're going to have more millimeters than centimeters. That basically it's going to be more. So this one, A, is not going to be right. So if you move this over, you're going to move this decimal point just over one place, because you're going from the hundredths to the thousandths place. So B. And you just look and think, 25.4 millimeters, is that equal to centimeters? Yes, centimeters and millimeters mean 1,000, and centimeters mean 100. What category are the elements fluorine, bromine, and iodine? Those are all, if you look on your periodic table there, they're all going to be what? They're all going to be in group 17. And all those groups in 17 are going to be called halogens, right? Chalcogens are oxygens, and the oxygen noble gases, they're going to be in 18. So, but halogens, fluorine, bromine, and iodine are all halogens, and they're going to be in group 17. Getting kind of tired here going through this whole time. It takes you a while to do them. So, number 36. In what category are the elements magnesium, calcium, and barium. They're all the same. So what are they? The alkaline metals, they're going to be in number 1. And none of those are in number 1. You look in your periodic table and see which number group they're in. Transitional metals, they're all in the middle, right? All the different groups. Alkaline earth metals, they're in number 2. And then the inner transitional are the weird ones at the bottom. Kind of the nuclear ones, I always call them the, basically the ones at the bottom. So anyway, if you look on your chart, magnesium, calcium, and argon, they're in number 2, which are the alkaline earth metals. What type of geometry does CH2O, in which 3 bonding pairs of electrons are arranged around the central atom? We have three bonding pairs. So how does this go? It's going to look like this. You have CH2O in the midst of this. It's either going to be planar or it's either going to be A or B, because there's 3, right? So CH2, this is a molecule by itself, and then the O. So you're going to have oxygen, and then you're going to have the CH2, and CH2. So they want to know which one it's going to look like. Well, because it's only, it's in the middle, it's going to be H2O, which 3 bonding pairs of electrons are around. So you have 3 bonding pairs. So it's either going to be this one or this one. I don't know, B or C. It looks like it's going to be B because it doesn't look like a tripod, huh? So which of the following elements would you expect to have the greatest electronegativity? Well, the one that is going to be clear over on the right side of your periodical table, it's going to be the one that's in 17. So sulfur is kind of in the middle, calcium's kind of in the middle, CS is going to be way over on the left, positive, but Cl is going to be in number 17, and it's going to have the greatest electronegativity. Strong, because it has 7 valence and it needs 1 more, and it turns into this negative island. Electronegativity means it's going to be negative, and that's chlorine. What type of a reaction is this? So, do you remember when we did these? These were kind of fun. So you have to say, is it a combination reaction? Is it single displacement? Is it decomposition? Or is it double displacement reaction? Well, basically, combination would be 2 that are combining into 1. Well, they're not combining into 1, are they? So is it going to be decomposing? Are they decomposing? Is 1 decomposing into 2? No. So it's not going to be, we know it's not going to be the combination or the decomposing, because you have one would be a combination with combining 2 into 1, and then you're going to have this one, you're going to have 2 that are decomposing into 1. So these 2 are opposite. So the double displacement, well, we don't have a double displacement. Double displacement is like they're playing, they're changing partners. They're not changing partners. So here we have zinc is changing a partner over here, but basically hydrogen's coming here, so you're going to have single displacement reaction. 40. So in what category are the elements boron, silicon, and germanium? When you look on your chart, you got to look on your periodic table, and you'll get look at where the metals are and the non-metals and the alkali, and you'll find that silicon, especially silicon, is a semi-metal. So it's not a metal and it's not a non-metal. Number 41. In the production of a metal part, molten steel at its melting point is poured into a mold and allowed to solidify. Which of the following quantities is involved in this process? The key is melting. Molten means melting. So heat of reaction, specific heat of formation, or heat of fusion. Heat of fusion is always melting. So molten would be heat of fusion. I'm going to skip 42 right now and go on because I don't have it all written here. So 43, what type of geometry does hydrogen telluride have? So here it is, our celluride, H2SE, which has 2 bonding pairs and 2 non-bonding pairs of electrons around the central atom, 2 non-bonding. So if you have 2 non-bonding and 2 non-bonding, basically you're going to have, so you have H2 and SE, so you're going to have H, you're going to have 2 of H, and then you're going to have, here's another H, and you're going to have SE. What does this look like? It looks like water, doesn't it? And what does water have? Well, it's not going to be linear, it's not in a line, because it has 2 of these up here like that, so it's going to be very, very polar, but it's not dipolar, so it's going to be very angular, because it basically is pulling these out to the angle, so it's going to be angular. Number 44. Which law of thermodynamics relates the change in internal energy to heat and work? Well, the second law of thermodynamics has to do with disorder. So the first law has to do with energy from heat and work first. There's only 2 of them. Number 45 here. The theory of light that states that light is in little packets, right, is electromagnetic waves traveling as bundles or packets. What do you call that? The quantum theory. Quantum. Went over that many times. Number 46. I'm going to keep going, even though it's getting a little long. The mass of a substance per unit of volume is called what? This is, okay, mass of substance, mass per volume is going to be density, right? A theoretical gas that exactly obeys the assumptions of the kinetic theory would be called an ideal gas. If it's theoretically, it's ideal. The outermost electrons in an atom, which are involved in a chemical bonding, are called what? What are those called? Valence, right? Valence electrons. There's those electrons in that outer shell that combine. The what cubic arrangement of atoms in a crystal has the least empty space of any cubic arrangement? The least empty space. So they're all packed in really tight. They would be face-centered, right? Because they're all tightly packed. Matching. Relatively strong force that exists between molecules that contain hydrogen. Hydrogen is the key, so it's going to be a hydrogen bond. Number 51. Moderately strong force that exists between neighboring key word is polar molecules, due to the attraction. It's going to be dipole. Number 52, a weak force that exists between all molecules, both polar and non-polar, due to the formation of instantaneous dipoles. London. London is in every single molecule. The strongest intermolecular force affecting the element iodine. I don't know. The strongest interpolar force affecting the element iodine would be the London force, because it can't be hydrogen because there's no hydrogen in there, and it can't be dipole because it's not a polar, so it'd have to be London force, and that's a very weak force. So 54, the strongest intermolecular force affecting the compound, and here you have this picture of the compound here. So what would be the strongest force? These are all, okay, this is hydrogen, chlorine, chlorine, hydrogen. So what would be the strong force? Of course, it's going to be, H is hydrogen. So it's going to, whenever you have an H, you know it's going to be hydrogen. That's the key. 55. Balance the following equation. You guys know, you should know how to do these. I kind of went over these, but balance. So you have ferrous sulfate plus oxygen here, gas. Make sure you put that all down. So then you look on this side and you see, Okay, this is really weird. The oxygen has 3 and this has 2. So now you're going to have to put a multiple of 6. You're going to have to change these both to 6. So you put O2 has 3, so I put 3 here. And then I have to put 2 in front of this to make this, so it's a multiple. So now we have, what, 6 oxygens on this side and 6 oxygen on this side. But I look at the ferrous, which is iron. I look at iron here. And so you have the iron part has 2. Well, if I put 2 in front of it, now it has 4. So I'm going to have to put 4. So I put 4 plus 3 O2 plus 2. And then I look here, oxygen, is it the same? Yep. Oxygen is 6 on this side and 6 on this side. 3 times 2, 3 times 2. And then iron, it's 4 and 4 on this side. So let's balance the next one. And here you can see how I balanced it. This one's harder because I looked here and you see here, okay, the nitrogen, but as you look here, you got hydrogen has 3 over here and hydrogen has 2 over here. So then I think, okay, what am I going to do? I have oxygen. So each one of these goes through this process. And so I'm going to not go over this process and stuff, but you have to change. You look at the nitrogen and keep balancing it out. And this one's a little more difficult. So drawing the Lewis structure of phosphorus trichloride, that means tri means 3 chlorides in phosphorus. So you have a chloride here, chloride here, chloride here, and 2 here. Now, I put a line there, but you can also put 1, 2, 3, 4, like this, all around each one. That would be Lewis structure. It has to have 7 around it. 1, 2, 3, 4, 5, 6, 7, and it holds like that. So that's your Lewis structure. Calculate the molar mass of benzene. This one you should go, it's basically you look at benzene. Benzene is this formula. Well, you look at carbon and you look up the molar mass of carbon. It's going to be, carbon is 12.01 per mole. And then you look, as you find hydrogen, it's going to be 1.008. And they have it right here, 12 sig fig 1.008. Then you're going to times this by 6, because there's 6 right there. 6 times 12 is going to be 72.06. Then you take the hydrogen times 1.08. And you can get this, you get these numbers right from the periodic table. They're right on there. It tells it the molar mass, how much the atomic weight is, you know. And so 6 times 1.08, and this is what you get. And you measure it out, 72 plus 604, and this is what you get. So on to number 59. Hydrogen and oxygen react with each other according to the equation, and they got the equation there. If 5 moles of oxygen react with a limited amount of hydrogen, what amount in moles of hydrogen will be produced? Okay, so we look at the moles. There's 2, that's that number, the coefficient 2. There's only 1 there, and there's 2. So you have 5 moles of oxygen, and you only have 5 moles. Yeah, 5 moles of oxygen to 2, or 1 mole of oxygen to 2 moles of water in the midst of. Anyway, all you're going to do is take how many they want. 5 moles. You have 2 to 1, and so really you just have to multiply it by 5 by 2, and you get 10. It's pretty easy. Last one. A sample of helium gas has a volume of 620 milliliters. And if we decrease the temperature while keeping the pressure constant, what will the new volume be? So let's just fill that in. We have volume right here. Here's the volume. Here's the volume. And here's the temperature. And here's this temperature it's going to change. So now we just put together volume 1 over temperature 1 and volume 2 over temperature 2, and you fill it in. So it'd be 620 divided by 500 K and equals V2. This is what we're going to find, volume 2 divided by 100 K there. So then I just filled it in here, and I find it basically V2 is going to be 100, because basically I'm just going to times this over on this side. So we have 100 K times 620 milligrams over 500, And so basically you can, right here, cross out the K, cross out the 2 right there. And so you basically, this is just going to be 1. So you're just going to divide 620 by 5, and you'll get 124 milliliters. So that's it.